All right, 8.2, we are now adding and subtracting our rational expressions. And because our rational expressions, when we add and subtract them, we need to have common denominators, the first thing that we're going to do is practice finding what will be our common denominator. When it's not set in a denominator, we call it a least common multiple instead of the least common denominator. So I know that this is something that you guys have probably done before with fractions, or not probably done, you have done it before with fractions, but you may not have done it with different variables or even with factors that include multiple terms. So that's what we're going to practice in A through F first. My method is probably a little different than what you used when you used just regular fractions. And of course, if you can recognize what the least common multiple is for the number part right off the bat, feel free to use that method. I just really recommend learning how to do it the other way, because you won't always be able to look at all the numbers and find a least common denominator right off the bat, or a least common multiple right off the bat. So, in taking a look at the first one, we are going to first do a factor tree for each of those sets. So 16, 8, and 5. If we were to do a factor tree for each of those, 8 and 2, 2 and 4, 2 and 2, we would see that the prime factorization of 16 is 4 2's, and then I still have an x, so 1x. So 16x can be rewritten as 2 times 2 times 2 times 2 times x. If we were to work out the prime factorization of 8, I know I have it down here, but just to help us, we'll write it in a different color. The prime factorization of 8 is 2 times 2 times 2, and I have an x squared, which you can rewrite as x times x, and a y. And the prime factorization of 5. 5 is already listed as prime, so there's not any sort of tree to make. 3 x's, 1 y. What you're looking for when you're creating these LCMs is which one of these has the most of each of the factors represented. So this has 2's and x's, this has 2's, x's, and y's, this has 5 x's and y's. So all of the factors represented are 2, 5's, x's, and y's. So we want to find out which one has the most of each of those factors. So which one has the most 2's? That would be the 16. There are 4 2's. Which one has the most x's? That would be this one. The last one. It has 3 x's. Which one has the most y's? That would be either one of these. They're the same, just 1 y. And the last one has the most 5's. So if I were to multiply all of that together, I would have 5 times 2 times 2 times 2 times 2, and that would give me a total of 80. Oops. Three x's, 1 y. Oops. 3 y's. I forgot a y up there. That's my bad. There were 3 y's here. So that means that the most y's are 3. So the most y's in my answer should be 3. So the least common multiple is 80 x cubed y cubed. That means that I could be able to take any of the factors that I started with, or the sets that I started with, and I would be able to evenly put it into this set. So 80 can be divided by 16, 80 can be divided by 8, 80 can be divided by 5, And the same goes with your variables. Let's do another one that doesn't have pluses and minuses before we jump down to the pluses and minuses. So we're going to move to C next. So the first thing we're going to do is do the prime factorization of C, or of 12C. 12, 6 and 2, 3 and 2. So 12 is made up of 2 times 2 times 3, and there's 1C. 6 is made up of just 2 and 3. 2 C's, 1 D. So now I'm going to look through and see which one has the most of each of the different factors represented. The most 2's represented in a factor is found over here. That's 2 of them. They both have an equal number of 3's. So we include just 1. This one has the most amount of C's, and it has the most amount of D's. So when I do 2 times 2 times 3, I get 12. 2 C's, 1 D. That is the smallest that either of the 2 starting sets could go into. Let's do one more without pluses and minuses before we move into pluses and minuses. So for D, I'm going to do a factor tree for the 18 and the 24. 3 and 6, 2 and 3. So 18 is made up of a 2, a 3, and a 3. 3 A's, 1 B, 2 C's. Now the factor tree for the 24. 3 and 8, 2 and 4, 2 and 2. So 24 is made up of 2 times 2 times 2 times 3. There are 2 B's and 2 C's. So when I'm looking to see which one has the most, I can see that the 24 had the most amount of 2's, 3 of them. The 18 had the most amount of 3's. There were 2 of them. I have 3 A's. The most amount of B's in any one of them is 2. The most amount of C's in either of them is just 2. So I have 2 times 2 times 2 times 3 times 3 for a grand total of 72. A cubed, B squared, C squared. Now the process for when we add multiple terms, the pluses and the minuses, is the same. We're going to factor these. Instead of using a prime factorization tree, we're going to use the methods that we've learned in the previous chapters to factor. That's looking for our GCFs, using the box method, and using any patterns that you may notice as well. So for the first one, the first thing that I see is I could take a 3 and a y out, leaving me with just a y minus 3 inside. The second one, you're going to want to use your box to factor that out. A times C, factors of that, which ones add to be -8, toss it in the box and take out your common terms. You may want to pause the video to be able to do that. You should have ended up with the factors of y minus 3 and y minus 5 for the second one. And the process remains the same. We are going to look and see which one has the most of each kind of factor. So this one has a 3 that's all by itself. It's a factor all on its own. It's not being added or subtracted anything. So I need to include that because this one has the most amount of them. Which one has the most amount of y's that are all by themselves? It's right here. Which one has the most amount of y minus 3's all by themselves? And which one has the most amount of y minus 5's all by themselves? Another method that you could use to do that is to write down one of the factors, or one of the factored sets in its entirety, and then take a look over here and see, is there anything that I didn't already include? I already included a y minus 3, but I have not yet included a y minus 5. There's my LCM. Let's take a look at E. First step is always to factor. I can take a 2 out, leaving me with x minus 3. And then the second one, it's already factored. So when I'm looking for the least common multiple, the first one has the most amount of 2's, and they have an equal number of x minus 3's. So the common multiple is 2 times x minus 3. Last one for the least common multiple. For F, we need to factor first. Here's that pattern that we've come to know so well. 2 perfect squares with a minus in the middle. Factors down to be just the square root of the first term, square root of the last term, 1 plus, 1 minus. And then the t plus 5 is already factored. So they have the same amount of t plus 5's. And this one has the most amount of t minus 5's. So my common multiple, or my least common multiple here, is t plus 5 and t minus 5. You need to understand how to do this part in order to be successful when you're adding and subtracting rational expressions. Because to find a common denominator for these rational expressions, you are going through this process that we just went through up here, plus a few extra steps. So to add and subtract rational expressions, they have to have common denominators. That is very different from what we saw in multiplying and dividing rational expressions. There, we didn't need any sort of common denominator. We just followed the steps. But here, when adding and subtracting, you have to first find a common denominator before you can do any sort of addition or subtraction. In order to find your common denominators, just like we did for LCM, you have to factor everything first. So in our example, we're going to factor everything first. So 5x does not factor, but the x squared minus 9, I recognize them as 2 perfect squares with a minus in the middle. So x plus 3, x minus 3 is what it factors to. And then the second one is already factored the way it is. So your first step should be to identify a least common denominator. That is the same thing as identifying a least common multiple. So in looking at these denominators, my common denominator, this one has the most amount of x plus 3's. They have an equal number of x minus 3's. So there's my common denominator. I have to make each of these fractions have that denominator. Now this one already has that denominator, x plus 3, x minus 3. So nothing needs to happen to the numerator. But over here, This already has an x minus 3, but it's missing an x plus 3. So in order to make it common, we have to multiply by the same thing on the top and the bottom. Now when I look at this denominator, it looks the same as what my common denominator is. So I can just, once I've multiplied those like that, I can simply add the two together. I have 5x plus 2 times x is 2x. 2 times 3 is 6. So 5x plus 2x gives me 7x plus 6 all over x plus 3, x minus 3. And always check to see if I can factor anything or cancel anything out afterwards. But 9 times out of 10, you're not going to be able to. Let's take a look at a few more problems. Now in A and B, these don't have separate terms in each of the fractions. So finding our LCD process is going to be like the first ones that we did when we found the LCM. First step is to factor out each of those using your factor tree. So this one is already factored. It's just a 5 and an x. But the next one, the 4 is represented of a 2, 2, and 3 y's. So finding the LCD, we ask ourselves which one has the most amount of each of the factors. So we have a 5. Most amount of 2's is 2. Most amount of x's is 1. The most amount of y's is 3. Which if you want to, you can go ahead and multiply that all together so that it looks nice in the end. But I really recommend that you leave it all separated out until we're finished. So when we go to set this up, we are going to have a denominator of 20 xy cubed for each of these. We have to make each of these denominators look like this denominator. So in looking back at the split out portion, it already had a 5, it already had an x, it needed a 2 squared, which is 4, and it needed a y cubed. So it needed a 2 squared and a y cubed. Zoom in on that so you can see it a little bit better. And for the other side, it already had the 2 squared. It already had the y cubed. It was missing a 5 and an x. Please don't be fooled to just think that we always multiply by the other denominator. It just happened to work out this way. So you can check to see if you've multiplied by the correct thing by looking at your denominator. I should be able to multiply everything in the denominator and get my common denominator. So 2 squared is 4 times 5 is 20. X, y cubed, 20xy cubed. 4 times 5 is 20. X, y cubed, 20xy cubed. So I know that I've done this process correctly. So on top, I have 2 squared times 12, which gives me 48. Y cubed times y gives me y to the fourth. And on the other side, I have 5 times 5, which is 25. X times x, x squared. And I've already done my denominators. They became the LCD. So I'm checking to see if there's anything I can take out of both of those on the top or on the top. There isn't. I can't factor them because they're not two perfect squares with a minus in the middle. So this just becomes my final answer. Let's take a look at B. All right, for B, I need to first find my LCD. That means that I need to factor out each of these. So 12, if you did a factor tree, you would get that there are 2 2s and a 3 and 1 A. For the 18, work out your factor tree. And I get that there's a 2 3s, an A, and 3 Bs. And when looking at the LCD, the most amount of 2's is here, 2 squared. The most amount of 3's is 2. The most amount of A's is 1. And the most amount of B's is 3. So my LCD, if I were to multiply it all together, 36AB cubed. So I know that in the end, I'm going to have 36AB cubed. So let's look and evaluate what was missing from each of these. 2 squared was already there, but this one had only 3. It needs one more 3. It has 1A, that's already there, but it didn't have the 3 B's. So it needs to be multiplied by 3B cubed on top and bottom. For the other one, it had 1, 2, but it needs one more. It had the 2 3's. It has an A, and it has all 3 B's. So it only needed to be multiplied by a 2 on the top and the bottom. Check your denominators to make sure that they multiply to equal 36AB cubed. 3 times 12 is 36AB cubed. 18 times 2 is 36AB cubed. So I know that I've multiplied by the right part on top and bottom. So let's find the top. 21 B to the fourth minus 1 times 2 is 2. They're not two perfect squares with a minus in the middle, so I can't factor them any more than I already have. Let's take a look at C. For C, we need to factor the top, factor the bottom for each of these. So you may want to pause the video while I factor these so that you can get some practice. So they are factored completely. So we need to find our LCD. They have an equal number of x plus 6's. And this one has the most x plus 3's. So you know when you go to add with common denominators, x plus 6 and x plus 3 is going to go in the denominator. Take a look at the first fraction. It's already got the common denominator, so I don't need to multiply this by anything. But the second fraction is missing an x plus 3. So I'm going to multiply the top and the bottom by x plus 3. So I have 4x. And then over here, I'm going to distribute. So I have 5x plus 15. So I've got 9x on the top plus 15. And on the bottom, I have x plus 6 and x plus 3. Here's an example of where we're going to try and see if we can factor anything, because I do see a common denominator across the top. I can take a 3 out of both the 9x and the 15. And it leaves me with x plus 5. And on the bottom, I have x plus 6 and x plus 3. Once I do that, I can see that there is nothing that I can take out of both the top and the bottom anymore. And there's no need for me to refoil it out. You can leave it like that. At least you are showing me that you are trying to factor it out. So that is my answer. Let's take a look over at D. I need to factor the top and I need to factor the bottom. So you might want to pause the video for just a moment so that you can factor both of those. You can see that the first one does not factor. But the denominator of the second one does. So when I go to find my LCD, they have an equal number of y minus 3's. They each have 1. And this one also has a y minus 9. So the LCD is y minus 3 and y minus 9. So I know when I add them together that I will have y minus 3 and y minus 9 in the denominator. For this one, it's missing a y minus 9. So we're going to multiply the top and the bottom by y minus 9. Over here, this one is not missing anything from the common denominator. It already has both of the terms, or both of the factors. So I have 8 times 9, negative 9, and 8 times y, plus 2y minus 5. So the 8y plus 2y gives me 10y. Oops, I forgot to multiply the 8 and the 9. So I have negative 72, not negative 9. So negative 72 minus 5 gives me negative 77. And my denominator It's y minus 3, y minus 9. And I can't take anything out of the top. So I'm going to leave it just the way it is. That's my answer. Take a look at E. Factor everything that you can first. I really encourage you for the next two to pause the video and work them out first, and then skip ahead and see if you get them correct. So I factored both of these completely. Now I'm going to look for their LCD. So this one is the only one with a 3, and it has just 1, so I need to include it. They both have 1 x plus 2, so I'm going to include an x plus 2, and this one has an x minus 2. Next, we're looking for what each of them need in order to make the LCD. For this fraction, it has a 3, it has an x plus 2, but it does not have an x minus 2. For this fraction, it has an x plus 2, it has an x minus 2, but it does not have a 3. So I know my denominator is going to be 3, x plus 2, x minus 2. And my numerators, I have 4 times x and 4 times negative 2. And here's where a lot of people make a mistake. We're actually distributing a negative 3 because we are subtracting, and I see too many times people forgetting that we're subtracting as we're working these out. So it's better to just distribute your negative. So I have negative 3x minus 3. 4x minus 3x gives me just x. Negative 8 minus 3 gives me negative 11. And of course, my denominator stays exactly the same. Let's take a look at F. Pause the video and factor everything first. Okay, so now we're looking at the LCD. Okay, in the LCD, they both have an x plus 4. A plus 4. They both, this one has an a minus 4. And this one has a 6. So let's take a look at what the first set of fractions is missing. It has an a plus 4, it has an a minus 4, but it does not have a 6. So I need to multiply by a 6 on the top and the bottom. Over here it has a 6, it has an a plus 4, but it does not have an a minus 4. So let's take a look at the second one. or the distribution. I have 18A plus 12. And over here, I'm distributing not a positive 7, but a negative 7. So it's minus 7A plus 28. All over my common denominator. So I have 18A minus 7A gives me 11A. 12 plus 28 gives me 40. That's all over 6. A plus 4 and A minus 4. All right, I'm going to pause it here. I pause the video here and I want you to try